Okay, section 3, chapter 9, example problems. This is the phasor section. The first example problem is about finding the phasor, and you want to find the phasor based on cosine. Okay, so find the phasor transform of this guy. Okay, how are we going to do? Okay, let me outline the steps really quickly. So the first thing I want to do is really to convert this guy to phasor. Okay, and then convert this guy to another phasor. Okay, now realize that between these two phasors there is a subtraction operation. Okay, there is a subtraction operation. Now if you go back and look at this summary, what did I say? When you're doing arithmetic on complex numbers, addition and subtractions should be done in rectangular or Cartesian form. Okay, so in order to make our life easy, what we are going to do is to convert this phasor to rectangular form. Do the same thing here as well, rectangular form. Then we can perform the subtraction. So we're going to get a resultant rectangular form. Now, that is not what we want. The question says, find the phasor. Okay, ultimately, we have to convert this to phasor. So, get ready with your calculators and come along for the drive. There is going to be a phasor to rectangular conversion and a rectangular to phasor conversion. Okay, all right, so let's start. The first thing we have is V equals to, I'm going to rewrite that equation, 3000 cosine 20,000 pi t plus 45 degrees minus 100 sine 20,000 pi t plus 30 degrees millivolts. Okay, so now let us see. This first one is really simple. Right? Is it 300 or 3000? Let me make sure I get it right. It is 300 really. Okay, really 300. So this part I'm going to write as 300 angle 45 degrees. That's the phasor transform, right? So for the phasor transform, we look at the magnitude and the phase angle. The exact same thing on this side as well. Okay, I'm going to look at the magnitude and the phase angle. Okay, however, I cannot quite do that. Why not? Okay, I can do that for the first one, but not for the second one. The reason is, see, the second one is in its sinusoid form, so I cannot directly convert it to phasor transform the way we have defined phasors. So I'm still going to write this as 300 angle 45 degrees because that is straightforward minus 100 sine 20,000 pi plus 30 degrees. Now, if I subtract a 90 degrees from here, this sine becomes cosine. Okay, so now I have expressed this guy in cosine form. Okay, so cosine, very good. So I'm going to write this as 300 angle 45 degrees minus 100 angle. So 30 minus 90 is minus 60 degrees. Okay. Notice that this minus is coming from here and this minus is coming from subtraction there. Okay. So let's be careful. So we have arrived at what? We have arrived at the phasor form. This is the phasor 1 and this is the phasor 2. What is the next step? The next step really is to convert both of them into their corresponding rectangular forms. Okay, now how do you convert r angle theta into rectangular form? Well, x plus jy is the rectangular form where x is r times cosine theta and y is r times sine theta. Okay, so going from polar to rectangular form. Okay, here for the phasor 1, the value of r is 300 cosine 45 degrees plus j sine j 300. Let me not forget that 300 sine 45 degrees. Okay, that's that guy. Minus, now I still have to take care of this, right? I'm going to write that as I can factor out negative 100, right? So negative 100 is factored out. Okay, or I can factor out 100. Now cosine negative 60 degrees plus j sine negative 60 degrees, right? Because I already factored out this guy. It is straightforward. So 300 cosine 45 degrees is 212.13. So this guy is 212.13 plus j times 212.13. Okay, so that is this guy and this guy is this. Similarly, negative 100 times cosine of negative 60 is half plus j times 0.866. Don't forget the negative sign, negative 0.866. Okay, so we can simplify this. It comes out to be 212.13 plus j 212.13. And then the second phasor is 50 plus, okay, 50 plus 86.6. All of that multiplied by j. Okay, so let's not forget the negative sign here. Okay, let's not forget the negative sign there. And then there's a negative sign over there, and there's a let's see, negative 50, and then there is a positive 86.6. This is a negative 50, and then there is a comes out something like this. Okay, okay, all right. Now what I can do is simply add. You see, there is the real part That is the reason why I said we want to perform our arithmetic addition in rectangular form because it really is dang it. So there is this 50 times uh, there is this 50 times j 86.6. Okay, now I can do it properly. So there is this um, real part that can be added together. Okay, I'm adding the real parts together, and then uh, the imaginary parts with the j, they can be added separately. Okay, they can be added separately. So now once I add this imaginary part separately, if only I can get a proper color, right, like that and this. Okay, now it's simply a matter of adding these two numbers. 162.13 is the phasor. 162.13 is the real part, and then when I add 212 and 86.6, I get J 298.73. Okay, so this is the result in rectangular form. So we are at this step now. You just have to convert to phasor form. Okay, how do we convert this to polar form or phasor form? Now think about this. The x value is given here and the y value is given here. How do you find the r? Because you're interested in the phasor form r theta. That is what you're interested in. R value, if you remember, is square root of x squared plus y squared. Okay. Similarly, the theta is tangent inverse of imaginary part over the real part. Once you do that, once you do the imaginary part over the real part, you will find out that the overall, okay, the overall, the polar form or the phasor form is 339.9 angle 61.51 millivolts. And this is the phasor form we are after. Okay. The problem says find the phasor form, find the phasor transform. Really, the phasor transform, what we have done is to convert the rectangular form into phasor. And then this rectangular form, we had to convert it into cosine and then transform it into phasor, right? Once we have the phasor values, 300 angle 45 and negative 100, negative 60, the next step was to convert them into rectangular form because we are interested in a subtraction operation. In rectangular form, it's just a matter of adding the real parts and the imaginary parts. That gives us the result in the rectangular form, then convert it into polar form. That's the answer that we are after. Perfect. Let's do another example.